This is our Math 158 homework discussion, not practice. Just like, remember, as we mentioned, you can't learn juggling by watching somebody do it, even though there's a tutorial that says this is how you juggle. Now, to juggle, you got to practice. And the same thing with these problems. You're going to have to work them, check the answers in the back, practice, practice, practice. Okay, so I've got my calculator handy, and I've got my textbook, and I'm looking at problems, and the first problem in 8.3 says to multiply, and the radicals are root 5 times root 6. The property here is you're just multiplying the radicands, so that's root 30. Notice that root 30, just as a reality check here, root 30 falls between root 25 and root 36. And we know the square root of 25 is 5, and we know the square root of 36 is 6. So we're going to say this is about 5.5. Let's do the same thing with these. The square root of 5 falls between the square root of 4 and the square root of 9. The square root of 4 is 2. The square root of 9 is 3. So this is about 2.5. It's probably closer to 2.25, but 2, let's say 2.5 just to put it there. Okay, 2.5. The square root of 6. Square root of 6 is also between the square root of 4 and the square root of 9. So it's also going to be about 2.5. And 2.5 times 2.5 is about, oops, let's try that again. 2.5 times 2.5 is about, says 6.25. We're saying, 5.5. At least we're in the ballpark. Okay. So for multiplying like that, this is the way to go. You simply multiply the radicands and you're finished. Okay, let's look at number 13. Number 13 says you're multiplying the cube root of 7x times, using the dot for multiplication, the cube root of 2y. And again, we simply multiply the radicands. We leave the index the same. So this is the cube root of 2 times 7 is 14, and x times y. That's it. These problems go fairly quickly. Number 21. Number 21, it says we're supposed to take the square root, this is the square root, of 64 over 121. Probably the easiest way to think about it is the quotient of 2 square roots. And each of these we know, 8 times 8 is 64, 11 times 11 is 121. That's the answer. Number 29. It's the cube root this time of minus 27 over 64. I'm going to put the minus sign with the 27. It really doesn't matter, but I'll put it there instead of out in front. And then I'll break this up. That's the cube root of minus 27 divided by the cube root of 64, just like I did it in the previous problem. This is 4, and this is negative 3. Okay, the next batch says simplify. This is number 37. It says simplify the square root of 12. Okay, so here's our upside down division again. 2, 2, 3, square root of 2 by 2 by 3. Because the index is 2, this is a square root. We're looking for pairs. Each one comes out front. So we have 2 times the square root of 3, simplified form. Number 43. Number 43. It says minus, well, that's just going to stay out in front of the answer, square root of 28. So the minus sign just stays, and we're going to break up 28. And we'll do our upside down division again. 2 goes into 28, 14, 2, 7. So we have 2 by 2 by 7. And just as in the previous problem, we're looking for pairs. That's going to come out front. So that goes there, and we're left with the square root of 7. Okay, number 49. 49. We have a cube root of minus 16. So let's see, index is odd and Radican is negative. Okay, we can immediately pull that negative sign out and deal with this. Makes it a little bit easier to deal with. Yes, for odd indices and negative radicans, that negative sign can just be pulled out. Okay, so now we have cube root of 16. We'll do our upside down division. 2 goes into 8 4 times, and 2 goes into 4 twice. So this is minus the cube root of 2 by 2 by 2 by 2. This time the index is 3, so we're not looking for pairs, we're looking for triples. And that's going to come out front. So the minus sign from here, the 2 from the triple, and we're left with the cube root of 2. So here's our final answer. I do have to caution you on this problem. Many students forget to write the index. And if you were to write this as minus 2 squares of 2, I have to mark it wrong. So throughout the entire problem, the index is 3. This is a cube root, and we have to keep that all the way through. Okay? That's number 49. Let's look at number 59. Okay, number 59. It says the sixth root of 128. Okay, so here's our upside down division. 2 goes into that 64, 2 goes into that 32, 2 goes into that 16, 2 goes into that 8, 2 goes into that 4, and 2 goes into that 2. 1, 2, 3, 4, 5, 6, 7. So I have the sixth root. Now, I suppose I can write these 7 2's here. Obviously, this would be tedious if there were 107, but I do have 7 because the root is 6. The index is 6. I'm looking for a group of 6. There it is. That comes out in front. So the answer is 2, 6th root of 2. That's what's left inside. And again, don't forget to write the index. Okay, problem 63. Now 63 is a similar problem, but here it has the added complication of having a variable in there, 72k squared. Now if we think of this as the square root of 72 times the square root of k squared, you may be concerned, oh, I remember that. He made a big deal about it. That was the absolute value of k. But in this set of problems, it does say assume variables represent positive numbers. Assume variables are positive. Well, if that's the case, then the square root of k squared is just going to be k. We do not need the absolute value. The absolute value of a positive k is simply the same as k. Okay, so with that in mind, we just have to deal with the 72. Let's do our upside down division. 2 goes into that 36. 2 goes into that 18 times. There we go. 2 goes into that 9 times, and 3 goes into that 3 times. And again, we can just, if we're in doubt, we can check here. I have 2 times 2 times 2 times 3 times 3. Okay, and sure enough, that's 72. Okay, so here's our problem. We have the square root of 2 by 2 by 2 by 3 by 3 by k by k. The index is 2. It's not written, but we know it's 2. There's a pair, there's a pair, there's a pair. Each pair comes out front. So we have 2 times 3 times k, and we're left with the square root of 2. So I would write that as 6k square roots of 2. Remember, for square roots, you don't have to write the index, even though we know it's sitting there as a 2. Okay, interesting problem. Let's try number 69. 69. We have negative. Okay, that's just going to stay there. We have a cube root of 27t to the 12th. T to the 12th. Okay, so we have minus the cube root. Well, 27 we should know is 3 by 3 by 3, right? Now, do I really want to write out 12 t's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. I'm glad it's not 112. There must be a better way than writing all these guys out. But let's just look at it this way. Because the index is 3, we're looking for triples. There's a triple. There's a triple. There's a triple. There's a triple. And there's a triple. We're left with, I suppose, we can put times 1 underneath. Okay, so all these triples come out, and the answer is going to be 3 times t times t times t times t cube root of 1, or 3t to the 4th. Now, obviously, the shortcut to get to this, we note that 3 goes into 12 4 times with nothing left over. So there's our 4 groups of 3, and there were no t's left over. And so we can do this without writing out 12 t's. Just don't forget the cube root of 27 as well. Whoops, you know what I did forget? Forgot my negative sign. I better go back and double check. Minus and minus. Okay. Let's see. The next one I've got is 75. And this says the 4th root of 1/16. And then they put r to the 8 and t to the 20th. Like that. Okay, so I'm going to write it as the 4th root. I'll put the r to the 8 and t to the 20th on top, and the 16 on the bottom. And then break it up. It's the 4th root of r to the 8. 4 goes into 8 2 times. And t to the 20th, 4 goes into 25 times. And the 4th root of 16. And you might want to know 16 is 2 by 2 by 2 by 2. Okay, so here's the final answer. R squared, t to the 5th, and 2. Okay, so again, I didn't write out 8 of these r's, but I was looking for groups of 4. 4 goes into 8 2 times. And I didn't write out 20 t's. That would have been a real mess. But 4 goes into 20 5 times. 20 goes into it 5 times, and that gave me my 5 groups of t. Okay, there's the answer to that. Let's try number 83. Number 83. We've got the cube root of 8 z to the 6th and w to the 9th. Okay, we should realize, I hope, that 8 is 2 by 2 by 2. There's a group. Now again, I suppose I could write out 6 z's. Please make it clear what a 2 is and what a z is. I always put a bar through my z's. I'm not going to write out 9 w's. Okay, so because the index is 3, we're looking for triples. There's a triple, there's a triple, there's a triple, and 3 would go into 9 3 times. So there'd be 3 triples in here. And all those come out front. So we have 2 times z times z. There's the 2, there's a z, there's a z, and then we're going to have 3 triples of w. So w, w, w. And we're left with just at the back end the cube root of 1, which we know is 1. Here's the final answer, 2 z squared w cubed. Okay? And again, being clear between the 2 and the z. Okay, 91. Number 91, we have the square root of y to the 11th and 36. Okay, so square root of y to the 11th and the square root of 36. Well, we know the square root of 36 is 6, so that's easy. But what are we going to make of this y to the 11th? Do I really want to write out 11 y's? I really don't. I want to divide 2 into 11, and that goes 5 times. So that gives us 5 groups of 2. But then we're left over. There's still one little factor of y left over. Okay, so this would be the final answer. And again, you don't have to write the index of 2, but if you wanted to, you could. Now, this is probably the first time where we had something left over. So I am going to go ahead and just do this out to sort of show you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, because it's a square root, we're looking for pairs. 1, 2, 3, 4, 5. There's my 5 pairs up here. Okay, so y to the 5th. Remember, each one of those would come out front as a single y, so there'd be 5 factors of y. And you do note that we have this poor guy left over at the back end, this y, square root of y, and that's what goes right here. Okay, so hopefully that helps clarify how that one worked. Okay, 95. And again, we have a variable in here. We don't. We have the 4th root of 48 squared. Well, I suppose if I had my calculator, I can just go ahead and play with that. Let's see if it works out nice and easy. I've got 48 squared, but I'm taking the 4th root of that, so I raise it to the 0.25 power. It doesn't come out nice. So there's going to be a radical here at the end. Let's think how 48 times 48 breaks up. Well, if I do 48, 2 goes into 48 24 times, and 2 goes into that 12 times. Okay? And then 2 goes into that 6 times, and 2 goes into that 3 times. So this 4th root of 48 squared, here's a 48 broken down. So that's 2 by 2 by 2 by 2 by 3. But we have another 48. So we have the same thing, 2 by 2 by 2 by 2 by 3. We're looking for groups of 4. This is a 4th root. There's a group of 4, and there's a group of 4. So each one would come out front. So that's 2 times 2. We're left with the 4th root of 3 times 3. So this is 4 times the 4th root of 9. And just to sort of double check and see if this makes sense, I have 4 times the 4th root of 9. Let's see, that's going to be 9 raised to the 0.25 power. Okay, sure enough, we get the same thing. This last little bit, though, is interesting. We can simplify that even further. And I'm going to use my fractional power to do that. So let's see, we have 9 to the 1/4. Right? But what do you know about 9? 9 is the same as 3 squared. So what I'm doing here is I'm writing this 9 as 3 squared. And then I'm going to use my properties of exponents. I can multiply the exponents. So this is 4 times 3, let's see, 2 here times 1/4 is 2/4, or 1/2. So 4 times 3 to the 1/2, which is 4 square roots of 3. So even though I wrote it as 4 times the 4th root of 9, I can also do it as a square root of 3 and actually have a square root button. So sure enough, I think that would be the simplest way to end that problem. Okay, let's see, number 99. Number 99. We can use the 10th root of x to the 25. No way I'm going to write 25 x's, but I don't have to. I know that 10 goes into 25 2 times, and I'm left over with 5. Oops, I'm left over with 5 factors of x, so x to the 5th. But then, doing the same trick I had on the previous problem, I got x squared. This is x to the 5/10. Remember, roots are on the bottom. Remember my azalea bush story. So this is x squared times x to the 1/2, which I'm going to write as x to x squared square roots of x. Okay, so I'm assuming x is positive here. It does say that, yeah, and the problem says x is bigger than or equal to 0. So we're okay. This is our final answer. We've simplified this radical. Okay, all the way down. Let's see, problem 101. Okay, 101 looks like a challenge. I've got the cube root of 4, and I'm multiplying that times the square root of 3. Okay, so I'm going to write this now as 2 squared to the 1/3, and I'm going to write this as 3 to the 1/2. I hope that doesn't bother anybody. We know that the cube root here is the same as the 1/3 power. Okay, so that makes sense. And we have 4, which I just wrote as 2 squared. Okay. So let's see. Now I have, this is 2 to the 2/3, and this is 3 to the 1/2. Well, the bases are not the same, so I cannot add the exponents. And the exponents are different, so it looks like we're sort of stuck here. So here's the trick. This is sort of a juggling trick, if you like. I'm going to write this as 2 to the 4/6, and this is 3 to the 3/6. Now, what I was trying to do is I was trying to make the roots the same. So I do know that 2/3 can be written as 4/6. 1/2 is obviously 3/6. So now let's see what I have. I've got the 6th root of 2 to the 4th times the 6th root of 3 cubed. Okay? So again, I'm sort of going back and forth between these fractional powers and writing it as a radical. Okay, but now why did I do this again? I did this because I wanted the roots to be the same. So I do have the roots the same here. So now I have the 6th root of 2 to the 4th, 6th root of 3 cubed, and now I'm going to put them together as the 6th root of 2 to the 4th times 3 cubed. That doesn't simplify any. Notice that 2 to the 4th, obviously I have 4 factors of 2. So 2, 2, 2, 2, and 3 factors of 3. I was looking for groups of 6. Nothing cleans up there. So I'm just going to leave this as the 6th root. I'll go to my calculator to figure out what that number is. We have 16 times 27. Right? So 432. 432. And that's as best you can do. Okay. Combined the radicals. Okay, let's see. Another one like that is 105. Again, read the directions. The directions tell you how to do this. This is problem 105. It says writing radicals with the same index, trying to get the same root. Here we have the square root of x, and we have the cube root of x. Okay, so this is x to the 1/2, and this is x to the 1/3. So this is x to the 3/6, using the same trick I did in the previous one, x to the 2/6. So this now is the 6th root of x squared and the 6th root of x cubed. And hopefully you can see that is the 6th root of x to the 5th. Right? 2 plus 3 is 5. And we're going to write this as a radical to finish it up. Oh, it is a radical. We've got the 6th root of x to the 5th, and that's it. I suppose if you wanted it as a fractional power, it would be x to the 5/6, roots on the bottom. Okay, 107 is a nice application of radicals. This is a geometry problem. This is a right triangle. The two short sides are 3 and 4. These are called the legs of the right triangle. You don't know the C, the hypotenuse, the long side. The Pythagorean theorem, if we call these short sides A and B and C, right triangle, we have A squared plus B squared. So you square the two short sides, add them up, and that will be the long side squared. So C is the square root of A squared plus B squared, which cannot be simplified. So for this problem, C is going to be the square root of 3 squared plus 4 squared. Let's see. Well, 3 squared is 9, 4 squared is 16. Okay, so we can add those up. So that's the square root of 25, and we know that answer is 5. 5. Okay, so this is in fact 5. Be careful. Don't go thinking mistakenly. This is a common mistake. Some students, I'm going to write big no here. Some students think C would have to be 3 plus 4 because somehow the magic square root would undo the squares, but not when they're added. Right? So don't do that. But if you do that, that's absolutely silly. Look at the picture again. Pretend these are 2 spots on the map, and you're looking for the straight line distance. And if you take the detour, it's 7 miles, 3 going this way, 4 going that way. That's a total of 7. That has to be longer than the straight line distance. There's no way that it can be 7 going the straight line. That can't be 7. It has to be much less than 7. So less than 7 has to be. Okay? The straight line distance is always shorter than the detour. Okay, 113 and 119 and 123, these were distance problems. So the distance formula, the distance between points in the plane, I can graph this one. Generally, you don't want to graph it, but I will anyway. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Woo! 7, 8, 9, 10. Don't have enough room here. Let me start my picture a little bit further down. 1, 2, 3, 4, 5, 6, and 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, way up there. Okay. So this is the ordered pair 6, 13. And the second point is 1, 1. Right here, 1, 1. Okay, so the idea is how do you get the distance between them? Again, you just imagine a right triangle. So we have to figure out how far going this way and how far going up. The going east-west direction would be the difference between 1 and 6, so that's 5. And the up-down direction, this here, would be the distance, would be the difference between 13 and 1, so that's 12. Okay, so good old Pythagorean theorem again. A squared plus B squared. C squared, A and B are the short sides. So 5 squared plus 12 squared is C squared. This is 25 and 144. C squared, this is 169. Is C squared. C is the square root of 169. C is 13. Okay, so the distance is 13. And again, just a reality check here. This has got to be shorter. The straight line distance has got to be shorter than if you did the detour. So if you did 5 and then turned north and did 12, that's a total of 17. And sure enough, the straight line distance is smaller than 17. Okay, how do you do this without drawing the picture? Well, the key was getting these numbers here. So how do I get the 5 and the 12? I subtract 6 and 1. How did I get the 12? I subtracted 13 and 1. So you're subtracting x's, you're subtracting y's, squaring them, adding them up, taking the square root. That's the distance formula. Let's do that on problem 119. 4.7, 2.3, that's 1 point, I'll call it A. Point B is 1.7 and negative 1.7, and we want to find the distance AB. Okay, so we're going to subtract the x's. Here's the x's. We're going to subtract those. So let's see, 4.7 take away 1.7. Well, that's obviously 3, and we have to square it. And then we're going to subtract the y's. We've got 2.3, and we're subtracting now a negative 1.7. Be careful there. So 2.3, we're subtracting the negative 1.7, so we're going to have to be adding. And we're going to have to square that as well. Each of these differences we have to square. So let's see what we've got. We did the first one, now let's do the second guy. So 2.3, we're adding now 1.7, right? Minus minus, so that's 4. We're going to square that. Boy, these numbers appear again. They were like the same numbers in problem 107. So we have the square root of 9 plus 16, which is the square root of 25, which is 5. Okay, so that's the distance AB. No picture. 123, you can't write the picture because there's no numbers. So we have x plus y and y. That's one ordered pair. I'll call it P. The second point is x minus y and x minus y and x. That's the second pair. And the question is, how long is PQ? Okay. So we're going to subtract the x's and square them. And we're going to subtract the y's and square them. Now, when I said x's and y's, what I really should have been thinking was the first coordinates. Here's the first coordinates. So we're going to subtract those. Let's see. X plus y, take away x minus y, is x plus y, take away x plus y, take away x plus y. Remember, you have to distribute this minus sign. Okay, so that looks like 2 y's. That's going to go here, y plus y, 2 y's. Okay, and then we'll do the same thing with the second coordinates. Not much we can do there. We're simply going to subtract these. So y minus x, and we have to square that. So let's see. Let me get rid of this work. And we'll just clean up the expression. So we've got 2y times 2y, so that's 4y squared. And then when we square this binomial, we have a y squared minus 2xy, and then plus x squared. Okay, so it looks like we have this now, remember, was 4y squared, and we have another y squared minus 2xy plus x squared. So not much we can do there. I suppose we could just leave it at the square root of 5y squared minus 2xy plus x squared. And I don't see any factoring there, so that would be our final answer. Let me pause this, check in the back of the book. Okay, so that checks out in the back. There's our answer, and I believe that was the last of the problems. Okay, so, yes, you can watch juggling, how to juggle, right? So we could try that, but what you really want to do is to practice these problems and not watch videos on how to juggle. Okay, I'll try to do another one on 8.4 before Tuesday night. I'll see you then.